This graph kind of ties everything together. You can see in the first section here, the first section, that we are ice because we are below the melting point and we're raising the temperature of that ice 40 degrees. So let's say that we had 50 grams of ice. I would have to take that 50 grams of ice times the specific heat of ice, which is 2.03 joules per gram degree Celsius, times the change in temperature, which is 40 degrees, to get the joules of heat energy absorbed to raise the temperature of the ice. In section number 2, we are starting to melt. And if you look here, the temperature is not changing. So if we used this change in temperature formula, we would put in a 0 change in temperature, which would calculate into no heat needed to melt something, which is not scientifically sound, which is why we have to use the latent heat of fusion. So we would take that 50 grams of ice times the 333 joules per gram to get the total amount of heat to melt those 50 grams of ice. Then in section number 3, we're now water. We're now water. We've completely melted. Which means that we can now raise our temperature again. So now our temperature is going from our melting point of 0 degrees to our boiling point of 100 degrees. So to get the heat to raise the temperature of that water, that 100 degrees, I would take the 50 grams of our sample again, times the specific heat of water, 4.18 joules per gram degree Celsius, times the 100 degrees increase in temperature, and we would get the amount of heat it took to raise the temperature of that water. In section number 4, we are now starting to boil. So again, during phase changes, there is no temperature change because that heat energy, instead of going into speeding up the particles, it's actually going into changing the state of those particles. So we're changing the distance between them and how they're interacting, and that's where that heat energy is going. So it's not raising the temperature, it's changing the state. And because there, again, is no temperature change, we cannot use MCAT because you'd put in a 0 change in temperature, which would equate to it takes no energy to boil something, and we've all made mac and cheese on the stove and know if you don't turn on the stove, your water's never going to boil. So you certainly have to put heat into that system. And just as a side note, if you're putting heat into the system, if that system is absorbing that heat, what type of energy change is boiling or melting? What type of energy change is that? Just think about that for a second. But I can then calculate the heat to boil all 50 grams of our water now by taking that 50 grams times the latent heat of vaporization, which happens to be 2,260 joules per gram. We're not ever going to calculate. We're never going to calculate the energy to speed up the particles of gas, but you could. We're just not going to get, we're never going to calculate that, so you don't have to worry about that last section. What if I wanted to know the total heat? What was the total heat to change my ice at 40 degrees Celsius, negative 40 degrees Celsius, all the way to change it all the way to a gas? I would just have to add up the heat from section 1 plus the heat from section 2 plus the heat from section 3 plus the heat from section 4. If I add those all up, then I will get the total heat for that complete transformation of our ice into steam.